Good morning, everyone. This is John Pendleton, your trainer today. Give us just a few more minutes and we'll get started. So just a couple minutes after 9 and we'll get started. Thanks. Good morning, everyone. It's John Pendleton again, your trainer today. If there's any veterans with us today, happy Veterans Day and thank you for your service. We appreciate it. We're going to cover the WV variable speed water-to-water unit today. This is our newest engineered unit from Intertech. It's quite different from our normal geothermal units, and that's why we have such a long training. In the future, I'm working on another project right now. When I get done with that, we're going to turn this webinar into a training video, so it's not so long. This is one of our longer webinars that we have. It's about 2.5 hours or so. So we're going to try to shorten that up a little bit in the future, but this is what we've got for now. It'll be the same training, just kind of broken down a little bit. Let me do something here real quick to my screen. Here we go. No, maybe not. All right. I guess it doesn't want to go away. So we'll go ahead and get started. This is our tech support department. So if you have any questions about the WV, you can always contact me. I'm the guy right in the middle of the screen there, a little bald-headed guy. We have 5 technicians available. If you do need assistance, with installing any geo unit, really, you can call the 618-664-5860 number, and that'll ring back directly to tech support, and one of us in the group will grab that call. You can also email us at technicalservices@intertechgeo.com. And we do have an after hours phone listed as well. That's not really listed anywhere else, so you may want to write that number down. That phone is a cell phone that gets rotated between us and tech support. And like I don't carry it during the normal business hours. A lot of times I'll leave it at home, but so try to call that number after 5:30 and before 7:30 a.m. Anytime between 7:30 a.m. and 5:30 p.m., someone in the office will answer your phone call. So that's the after hours phone number, 267-1768. We do have some design help. So if you're trying to design a WV for a home and you've got questions, we can get you in contact with either Angelique or Jeremy here, and they can assist with helping you figure out what unit you may need. They also do equipment sizing, loop sizing, pump sizing, GeoAnalyst software, older unit replacements. So if you have an old Bosch unit from 1972 and you need it cross-referenced over to a newer Intertech Geo unit, we can look up that information and get that unit replaced for you. We also do a lot of solar design. So if you're interested in solar, hit me up, shoot me an email or something. I'll get you some information on that. But they do a lot of the sizing for the solar and basically work with a program where it designs the panels, whether they're going to be a ground mount or a roof mount. But they can definitely talk to you a little bit more about that if you need some assistance. They do have a direct line as well, the 690-3344, and an email. If you're going to have a solar quote, they're probably going to need some utility bills. So if you need to email those in, or you got pictures or something you need design to see, you can email design services at intertechgeo.com. Angelique and Jeremy also have their own individual extensions, and they'll be willing to give that out to you once they talk to you. We do have a dealer secure website that we would like you to go and sign up on. Basically, you can go to the support secure area and put in your user information and password, and then you can get into the secure website. You can also access Enertech University through the website. In the upper right-hand corner, it says Enertech University. If you click on that, it'll take you to the Enertech University page. And there you can see any upcoming trainings. There's a link to our video library for all the webinars that we do. If you'd like to check those out, they're on YouTube. And our YouTube channel is Enertech University. So pretty easy to remember there. So you can, all our webinars are recorded. Today's is going to be recorded. So if you miss something today, you can go back and watch the recording again. And they're all free. You just have to subscribe to our channel on YouTube. This is the Enertech University page. And so you can click on the curriculum. It'll give all the different courses we offer. And then if you scroll down on this screen, when you come to the main page, it'll show the upcoming trainings. And then here's the link for the video library as well. So on to the WV, the variable speed water-to-water unit. It's capable of doing heating, cooling, and optional 100% of your domestic water needs. Now, when I say 100% of your domestic water needs, if they've got a large garden tub or a 4-head shower or something like that, it may not be able to keep up with that. So there may need to be maybe a backup water heater as well. And we'll discuss some of that when we get to the hydronic piping. But if it's a normal shower, there's no problem with taking care of your 100% of your domestic hot water needs. There's a variable speed compressor, and we have two units, the 040 and the 060. So the 040 is about a 3.5 ton, not quite 3.5 ton, but almost. And then the 060, which is a 5 ton. So the 040 will range anywhere from 2 tons to 3.5 roughly. And the WV will range anywhere from 2 tons to 5 tons. And it's basically the RPMs that will change, and then the capacity will change along with that. There's higher available load temperatures on this unit. We can get up to about 135 degrees. Obviously, the lower water temperature we can use, the better, because it's more efficient. but we can go up to the higher water temperatures. We use an internal variable speed load pump that maintains your temperature difference, or your delta T, across the load circuit. So it'll throttle and base its speed on the delta T. It basically tries to maintain 5-degree delta T across the load in and the load out. There is a connection that will control the external variable speed source flow center, and it can basically it monitors temperature difference as well on the source side. There's an internal electric immersion heater, and it's used for auxiliary or emergency heat, and it is a 2-stage 9-kilowatt heater. So the first stage of that heater would be 4.5 kW, and the second would be the other 4.5 kW. We do have an outdoor temperature sensor that comes with the unit, and that is used for outdoor reset control. If for some reason you can't mount that thermistor right away, or it's broken or something like that, we forgot to package it in the box, the unit will still run without that. You can set it at a set temperature, and it'll run at that temperature. But outdoor reset, we would like to use the outdoor reset. So as long as you've got that thermistor and it's working properly, we always recommend using the outdoor reset control. We have an on-demand zone control with multiple set points. Basically what that means is if you've got a radiant zone, the heating for that radiant, the hot water for that radiant zone may be a different temperature than what you get if you have a hydronic air handler. Obviously, in a hydronic air handler, we're going to want warmer water temperatures to get more heating capacity out of it. So, we want a higher water temperature. We may not want that in the floor, because the floor may have, they don't want to see over, let's say, 90-degree water. So we wouldn't want to send 120-degree water to a floor zone that the max that it wants to see is 90 degrees. So the controls will realize if it's a hydronic zone call, or a radiant zone call, or a forced air zone call into the zone controls, and then it'll base its temperature output on what call it's receiving. AHRI ratings, we'll show it here in the next chart, but we basically, the heating capacities are based on 32-degree entering source temperature and 104 entering load. And on cooling, it's 77 on the source and 53 roughly on the entering load temperature. Normally, they design the floor heating for around 85-degree entering load temperature. So we're leaving about 90, 95 degrees. Here are some capacities. If you look on the top chart, this is these are the 060 ratings here. And then you can see, kind of compared to our standard 2-stage water-to-water unit capacities of it. And you can see the EERs and COPs of the unit. So definitely more efficient. Capacity is pretty much the same as the WTO60. So capacities aren't really a real factor there. But you can definitely see our EER and COPs when we're in part loads, which we're going to be running on the WV and part load at some kind of part load quite a bit. So that's when we really gain our EER and our COP, or our efficiencies. We do have a little bit more of an expanded chart that'll show you the different RPMs and what the capacity and COP is. So you can see at 2600 RPM, we're running about a 3.9 with a capacity of about, half roughly at 26,000 BTUs. So, and then when we're running up at that higher RPM range, normally I don't see the units go much above about 6,500 RPMs. And at 6,000 RPMs, you're going to be at about a 3.0 COP. So if you need to know these efficiencies a little bit more, it is in our IOM. You can access these IOMs if you're GeoComfort, you can go to geocomfort.com. If you're TechCo, go to techco.com. If you're at Hydrogen Module, go to hydrogenmodule.com. Click on products, and then click on residential products, I should say. And it'll bring up a bunch of pictures of all the different units, and you can click on the WV unit, and then you can get to our documents, and you can pull up the manual. You can also contact us in tech support, and we'll happily email you over a copy of it as well. We can always grab one off the shelf and mail it to you if you need a hard copy. Either way, just let us know, and we'll get that over to you. Some of the cooling efficiencies here, we're running about, midway, 42,000 BTUs. I'm running about a 15.5 EER. So just kind of some ranges of our cooling efficiencies. Again, this is all listed in the IOM as well. If you really need to break it down to different water temperatures, other than what we showed in our HRI ratings, in our manual we do have a heating capacity that will show full load heating, different RPMs, and different water temperatures, and then you can see what the heat of extraction is at your different water temperatures. And that's the same way for the 040 or the 060. We've really got it broken down pretty well in our spec manual there. The water heater, we only offer one type of water heater. We'll get into the water heater here in a little bit further, but we have two models available, the 040 or the 45 and the 65 gallon tank. So this is a comparison of, if you've got an electric water heater or a gas water heater, what size should you get? This kind of helps you size for your proper domestic hot water. So recommended applications, high mass radiant floors. You can do hydronic forced air. You can zone that air handler. Again, 100% of your domestic water needs. And as we move along, we will come up with new control strategies. We've actually changed some controls already, some external controls, and actually even some piping upgrades as well. So, it's kind of a learning experience sometimes when we have new equipment out there, and we learn as the unit runs in the field under true conditions, we learn more and more about it. So we change things as well. So really, like, our piping is different now than it was 2 years ago because we found issues with air and things like that. So, we're learning just like you guys do as well. So we do make changes to the IOMs, sometimes change some parts and things like that. So normally we try to let you know when we've made a bigger change, like a piping change, so you're not totally surprised when you get to the unit. I have already updated this training here to match the IOMs that we have currently. So we do have a WV selection chart, and I can actually go to it here possibly. So this is a WV selection chart here, and you're gonna have to run it if you've got multiple units in the home. You have to run it for each unit. But basically, you can click on it, click your brand, what size unit you would need, whether it's residential or commercial. It doesn't really affect the way the unit's built or anything. It has more to do with warranty and that kind of thing. But a lot of them are going to be the residential. Here you can choose your hot water configuration, whether you're going to have it or not. Your flow center option, you can get a pressurized 2 pump, a pressurized 1 pump, non-pressurized 2 and 1 pump. They're going to be a variable speed flow center with the unit as well. We'll talk about the hydraulic separator a little bit later. It's a new option. You can use either a hydraulic separator or a buffer tank, and we'll talk more about that here in a little bit. But I just wanted you to see that's a newer option, probably within the last couple of months, whether we have a hydraulic separator or a buffer tank. Your hydronic system pump option. If you have a hydraulic separator, we're going to have an external pump. So here's where you can choose a constant speed or a variable speed external pump. And then you can choose your tank option. Type of controls, we'll touch base on the controls a little bit. We won't dive real deep into it as far as how to actually wire it. We'll show the different wiring diagrams today and show you your options. And so we'll get into that a little bit more. But we basically have either HydroConnect, which is a Geoflow product and uses the TACO zone control board, or we have the EWC zone controls. You can choose your thermostat types here, whether you want programmable and Wi-Fi, non-programmable, touchscreen. So choose your thermostats there. And it'll ask how many radiant zones, how many air handlers, type of air handlers, whether you're going to do cooling only or heating and cooling. Is it going to be a zone ducted unit? So just some more options. Once you fill this all out, it's going to spit out a model number for you. It's going to base this model number on all the options that you've put above. And then it's going to basically put out a list of what needs to be quoted for the job. So you could even print this out. You can send it over to customer service and they can quote this for you. So it'll list all the things that you're going to need. Other items that you might need to add to the estimate, you know, an air handler, filter rack, things like that. And then it'll also show items included with the WV listed. So it'll list your Y strainers, your FPT adapters, differential bypass valve, your tanks. So it'll actually spell out what's all going to be in the box for you. That's basically the WV selection chart. We also have some Geoflow design calculators that work well if you need to size the pump, especially if you're going to size the external pump for your zones. Geoflow is real good about not sending you a bunch of junk email and stuff, so I would recommend going to Geoflow, to their website, and creating an account. And then you can click on the design calculators. And they have quite a few on there. They have loop sizing calculators, pump sizing, all different kinds of calculators there. So I'm not trying to, you know, get you to buy Geoflow all the time or products or things, but we work really close with them, and they've been a really good vendor for us. And again, they've got some great design calculators on there, so definitely check them out. Loop field sizing, we would recommend using the Loop Link software to calculate your loop length. If you're using the domestic hot water option, you may need a little bit of extra loop because we do have extended run times that come with the variable speed. So we do suggest adding extra loop. If you got any questions on that, give us a call and we'll have you talk to the people in design and they'll give you their take on that. Standard sizing of the total load is applicable, but you may want to add it for the add more loop for the domestic hot water. Some of the features, again, it is a variable speed compressor. It's a Copeland scroll with inverter technology. There's two brazed plate heat exchangers in there, one for the load, one for the source. We're using an electronic expansion valve or an EEV or EXV, whichever you like to call it. We have to use the electronic expansion valve because of the variable speed, and a thermal expansion valve won't respond quick enough for us. So we're going with the EXV. One thing that is nice about the EXV, we probably won't have an issue with it being restricted. It's powered open and powered back closed, so we don't have the problem with the piston getting stuck because it's driven both ways. The only thing that might fail would be the head on it that tells it where it should be. But I don't know that, maybe we've had one that had an issue, but no real problems with the electronic expansion valves. Again, we have an internal electric immersion heater for backup, emergency, auxiliary, however you want to look at that. There is a internal three-way valve that will switch from your radiant heating to your domestic hot water function. It does have an onboard HMI, which is a human machine interface. Basically, it's how you do all the setups. You can look at that screen and it'll tell you the operation of the unit. It's right on the front of the unit. And there is an internal Grundfos load pump as well towards the top of the unit. Here's kind of a little CAD drawing of the unit. You can see this is the front. You can see the HMI in the upper left corner, and then just some of the refrigerant piping down below, and the electricals in the upper portion as well. The key components of the heat pump. So we have the EV2, that's the big white box with the round, look like capacitors upside down on that. That's the EV2 drive. That's basically what controls the compressor. Tells it what speed it needs to run and throttles it, things like that. HMI, which is in the middle of the screen on the very bottom, that's the human machine interface. We have controllers. We've got an iPro controller, a breakout board controller. We've got flow switches. We've got flow sensors. We've got pressure switches and pressure sensors. We're looking at actual flow, so the sensors will tell the unit what kind of flow we're moving. The unit needs to see roughly 5 GPM or it's going to lock out. So it's going to look at this flow switch and your flow sensors. When it does fault out on flow, it'll tell you flow feedback or flow switch or both. So if you have, let's say, a flow sensor that's faulting out a flow feedback, so it's not seeing the feedback signal, but the flow switch is not locking out, I would say we probably don't have really a water issue. We may have some air in it where the flow sensor is not sensing, but if you get both of those faults at the same time, then we know, hey, we're probably not moving water. The flow switch is just a paddle switch. To be honest, the only reason we really have a flow switch on here is because the braze plate manufacturers require us to use a flow switch whenever we're using the braze plate. So we want to use the sensors, but SWEP says, no, you got to use a flow switch, so we use both. We have thermistors on the unit that are checking temperatures at different areas as well. There's quite a few of those. So you'll see a lot of little wiring running down to your refrigerant piping and hidden underneath insulation and things like that. So they're used for diagnostics and troubleshooting. There is a removable terminal strip. It's a green strip in the middle top of the unit in the control box. And that's basically where all your calls will come into. And you can remove that and jumper the unit. The terminal strip, the wiring coming into the terminal strip are dry contacts. There's no power there. It's just a contact closure that completes the circuit. So if you're at the unit and you don't want to jack around with the thermostat or the aquastat to get it to run, you can pull that terminal strip and just put a Y1 and a Y1C call is a low heat call. It's like a radiant call. If you were to jumper Y1 to Y1C with just a little wire, the unit will come right on, or it should. Let's put it that way. We do have a reversing valve in the system. And in the middle of this screen is the electronic expansion valve. And then the box to the right of the expansion valve is what controls that expansion valve. It's got some lights on there that'll flash at you, and it'll say open, close, TX or something like that. So when it's working, those should be flashing at you. This is the Copeland's scroll compressor with the inverter. You can see kind of the inverters next to it there, but it looks just like a standard Copeland scroll compressor. There's not really a whole lot different look to it at all. This is the electric immersion heater. If for some reasons it leaks, there are some unions that are threaded onto it, and so you can get it out of the system if you need to. The only reason I would think that one of these would fail if you ran it without water flow. So when you get the WV, you don't just get a unit. We don't sell just the unit. It comes as a package. So again, that's why we have to fill out that WV selection chart. And this is what it's going to give you. You know, if you ordered it with a tank, you're going to get the tank, the unit, the flow center, and your controls. They're all going to be a package deal. Moving and storage, make sure you're moving it in the upright position. We don't want to lay it down. Do not stack the WV units. Do not store the unit outside. It is not made for outdoor operation. And due to the weight, utilize proper hand trucks, stair climbers. There's a lot of weight in the bottom of that, a lot of dead weight. There's 2 braze plates. There's a heated or a compressor in there and some other parts. So pump. So they're kind of dead weight in the bottom. So make sure you're a little careful with how we're moving that unit. Pre-installation, make sure you've got the correct unit, whether it's an 040 or 060. I hate for you to install the 040 and you need an 060 and then it won't keep up. So make sure you've got the proper unit and all the pieces that come with it. Inspect the electrical connections. Make sure you got good contacts, especially the main power lugs. They're a screw fitting or a connection, and sometimes those can get a little loose in shipment. Verify there's no refrigerant tubing that's touching each other or has any kinks or anything like that in it. Pull that manual out, browse through it, read it. Become familiar with the unit before you just start throwing the unit in. Look at the components and the control setup. This is kind of nice because it kind of will walk you through a little bit when you do your startup wizard. And we'll cover that here in a little bit as well. But a lot of it's going to be walking through your controller. The controller can be a little bit tedious at times, especially if you haven't worked with it before. So it may take you a little bit to get a little bit used to it. So definitely check out the manual. I'm not saying you got to read every single word that's in that manual, but definitely look through it, browse through it, become a little bit familiar before you just throw it into the mechanical room. Once you have installed the unit, we would recommend you fill out the installation form that's located in the back of the IOM. And I would recommend that you make a copy of it and put it in your job folder, at your office. And then also you may want to leave one at the unit. That way, if you've got maybe a technician that doesn't know quite as much about geothermal or WV in general, if they go out there to work on the unit, they can pull that out and take a look at it and see how the unit was running on startup and maybe compare, and it'll help them kind of diagnose the unit. But always fill out the startup form in the IOM. So in the unit, these are all the parts and pieces that are going to come with it when you order it, just depending on the type of unit that you have. So there'll be zone valves, turbomax tanks, double O-ring fittings, strainers, that kind of thing. So this is also listed in the manual, and there are some notes that, like if you got an automatic air vent, it needs to be installed in the highest point of the system. Here's our part number, and should you order it with a new unit, and so forth. So obviously there could be numerous power sources in the unit. You're going to have a power source for the electric backup heat, as well as the geothermal unit. So just be careful when you're sticking your hands in there. I'm sure you guys are pretty used to working around high voltage. So you're pretty careful. So, but I always just like to mention that. A little bit of the nomenclature overview. The brand is going to be your first digit in the nomenclature. So G for GeoComfort, H for Hydrant Module, and excuse me, T for TechCo. The next digit is a type of unit. A W stands for water-to-water unit. And the next digit after that is the staging. You're probably used to seeing a T there because a lot of our units are two-stage. This being variable speed, we'll use a V there for variable. The next, the 060, that's either going to be an 040 or 060, and that's the tonnage, max tonnage of the unit. The next is a revision code, and that's if we were to change, let's say, a compressor or the drive for the compressor to a different part, we would probably change the revision on the unit. Something major is changed when the revision changes. It's a good piece of information for tech support. It doesn't really mean a whole lot to you. $208, $230 single phase, so you just have a 1 there. The next digit is your hot water configuration. 0 would be none. 9 is the indirect hot water tank. Then you have your flow center option. So it's pressurized, non-pressurized, 1 pump, 2 pump. It's just going to depend. So you have A, B, C, D, or E. If you have multiple units, we'll need to know that because you may just have 1 flow center. You could have 2. You could have, multiple flow centers. So it's going to depend. But the next is your tank option. You have a 0, 1, or 2. So none. Should be 45 and 65, not 48 and 72 is listed here. But then the next is your load and your source heat exchangers. We only offer a braze plate. And then SS at the very end stands for standard stock. If we were to add something to the unit, you might see, like when we add soft starts, factory installed soft starts, that SS changes to RS. So if we were to add something to the unit, we would note that in those 2 last digits there. Model or serial number overview. An example of our serial number is an M17091111. Really, all you need to know is the M stands for Mitchell built. So it's built in Mitchell, South Dakota. The next 2 digits are the year, so it would be 2017, and the next 2 after that are the month. So it's pretty easy to figure out how old the unit is. So this is September of 2017. The next 4 are the number of the unit in the month that it was built. Doesn't really mean a whole lot to you or to me, to be honest. So you don't really worry about that too much. Unit location. Care should be taken when units are located in unconditioned spaces to prevent damage from water lines or excessive heat. A humid area is not a good area either. It's going to cause boards to fail prematurely, rusting of the cabinets, things like that. So I would not recommend putting it in an unconditioned space, like a crawl space or an attic. A garage is probably okay. It's going to stay warm enough in there, and it's not going to have any real effect from the weather in there. So a garage may be okay. Attics get kind of hot in the summer, so it could cause the drives to overheat, or there is a inverter fan on the unit that keeps the controls and the components cool. So if it gets too hot in there, it will lock the unit out. Make sure that we're always giving a way to be able to service the unit. Serviceability, at some point, the unit's going to have to be worked on. That's just the way the equipment is. And so serviceability is always priority number 1. I would say, 2 foot around the entire unit, but that's a perfect world. If you can't do that, we would recommend at least the front and 1 side. The back side is where the water lines come out, and you'll see it here in a few minutes. So you got to have a little bit of clearance in the back of the unit. So we've got to keep it off a wall so you can run your hose kits out the back of the unit. We do recommend an insulated and isolated location. The unit is pretty quiet until you take the door off. So I wouldn't leave the door off the unit. And what you'll hear is the compressor. It's got a real winding sound. It almost sounds like a regional jet getting ready to take off. It's got a real whining sound to it. So with the door on, you can't really hear it. With the door off, you definitely can, especially when it gets up to those higher RPM ranges. Hang on one second for me. All right, sorry about that. So dimensions of the unit, and it doesn't matter if it's the 040 or the 060, they're the same size, same cabinet. So they're 25 inches wide, 25 inches deep, and 37 inches tall. So not real super big. Again, we do suggest 2 foot around the entire unit, and it needs to set on a solid pad. We don't want to use the corner shims. There's a lot of weight in the middle of that pan that's holding everything. If we don't support the pan, then you'll start to get some vibration. You could actually have the compressor fall to the bottom of the unit because it could actually break that metal over time. It weakens it. So I would recommend not this air foam pad that we're showing here. We have a newer pad. It's about a 1 inch thick, but it's a rubber pad. What we found, again, over time, we learn things. Over time, sitting on these air foam pads, there's a lot of weight in one side of the unit, and it'll start to lean that way. And for one, it's just not a good look, and then the unit's not level. So with the rubber pad, it's not going to sag over time. It'll keep that unit level. And it'll also help if there is any kind of vibration. The air foam pad will help as well, but the rubber pad definitely will help with any kind of vibration being transmitted into the floor from the unit itself. This is the case cooling fan. We do have a filter part number. It's an RF119. To be honest, you could take some fiberglass filter material and cut it to size and put it in there, because that's basically all it is. It's just cut nice and neat for you. So, if you don't want to order it, or if you see that it's dirty and you don't have one, the RF119, then you can just make one out of some filter material that you might have on your truck. It'll probably need to be replaced about once a year. It's going to really depend on where it's sitting, how dusty the area is. But again, case inlet fan's got 2 little quarter turn fasteners on it. You pop those, pull it off, and your filter material's right underneath there. Don't operate it without a filter in there, because then you're going to get all that dust and debris on your controls, and that could definitely short things out. So we do require a 4-inch clearance on the sides of the unit so that we can pass air through that cabinet. This is the back of the unit. I talked about the water lines coming out the back, and here they are. They're all double O-ring fittings. You've got your hot water out, load in, which is your common for your hot water or your load, and then your source in and your source out. You're also going to have strainers on your source in and your load in connections that come with the unit. Again, anytime we have braze plates, the braze plate manufacturer requires us to use a strainer. Those passageways through those braze plates are pretty small, so we want to make sure that we're capturing any kind of debris that could be in the system or out in your piping. This is the top of the unit looking down. You can see there's a load pump. There's a door on the back side that you can kind of access it, but if you have to replace it, you're going to have to pull the top off the unit. So make sure we've got some clearance above the unit as well, so we can get in there and work on it if need be. Next to the load pump that little orange box, that's your three-way valve for shifting from domestic hot water to your hydronic load water. So general installation practices, all Intertech and geothermal heat pump installation practices, procedures, and recommendations apply to this unit as well. So we still have to flush, we have to fill and flush the loop field. There's no difference there. We still have to fill and flush the load side. There's still electrical wiring, the same. Setting and piping the unit, not a whole lot of difference. Make sure we're insulating the load and the source piping, and we're still using the general installation practice of 10-foot max total length on our hose kit to our flow center. So the flow center needs to be about 5 feet from the unit. 5 foot there, 5 foot back equals 10 feet. We'll talk a little bit about the control strategies on the unit. So we have on demand. So the heat pump only operates if the zones or the hot water tank is calling. So no buffer tank is required, but you have to provide sufficient flow. The unit has to see 5 GPM. I think it actually is a little bit under 5 GPM, but 5 GPM is a lot. It's easy to remember for you guys, and that's going to keep you safe. So we've got to have that 5 GPM. Now we can use this with a buffer tank, and we'll cover that a little bit, or I should also say a hydraulic separator. You could also do a dump zone or a primary secondary loop. We won't cover those last two. I'll show you the buffer tank and the hydraulic separator here in a little bit and talk about those when we look at the piping, but we won't discuss the dump or the primary secondary loops. Source water connections, again, double O-ring fitting, 5 feet. Right below this flow center in the picture on the left, there's a strainer. Make sure it's in the direction of flow, and it's somewhere where you can access it to where if you need to clean it out, you can get to it. The picture on the right is just showing basically a non-pressurized flow center. The picture on the left is a pressurized flow center. Regardless, whether you have pressurized or non-pressurized, we still got to install that strainer. So this is the typical load piping when there is a hydraulic separator incorporated into the design. Basically with a hydraulic separator, the hydraulic separator is like a small buffer tank, basically. You're decoupling the flow requirements for the unit from what your flow requirements are from your zoning. So you have the hydraulic separator, you've got an external system pump, you've got some flush blocks in the external piping. Oh, sorry about that. Flush blocks, so you can flush your zones. And so if you need 5 GPM going through the unit, and the zone that you have only needs 3 GPM, the hydraulic separator, you're going to flow into the hydraulic separator, you're going to pull back out of the hydraulic separator to the unit. So the unit's still going to pull that GPM that it needs. And then the zone is going to pull from the hydraulic separator the flow that it needs. So the hydraulic separator will also capture any dirt or debris, and there's a blowdown valve on the bottom of it. And it will also collect any air and will vent that air out if it gets back to the hydraulic separator through the air vent on top of it. And we found that we get micro bubbles and things, and they want to get stuck in the load pump that's in the WV unit. So it wants to lock out on flow, and we flush, and it's fine for a while, gets more air in it. So with this setup, we're not as apt to go out on some air in the system lockouts because it should be vented at different areas. We're even going to put, if you have, here we've got, 3 radiant zones and an air handler in here. That's that box right by where it says note 7 is. So these radiant zones may not take all the flow that you need. So this hydraulic separator will allow the unit to still see its proper flow and not really worry too much about what the zones flow. We also do recommend putting an automatic air vent in the highest point of the system as well to eliminate any micro bubbles or air in the system as well. If you're going to use a buffer tank, now if we're going to use a hydraulic separator, we would use the hydraulic separator anytime we have radiant zones or an air handler that's larger than 2 tons. That's when we're going to use the hydraulic separator. If we have an air handler that's smaller than 2 tons, then we want to go to the buffer tank instead of the hydraulic separator. And again, we're going to have an external pump for your zones, some flush blocks on your external piping, an air vent on your high point of the system. And then again, it decouples the pumping needs for the unit and the pumping for your zones. You can kind of see here to the right that we have the TurboMax water heater and an optional or recommended electric or gas water heater for backup. If for some reason the load pump inside the WV unit fails, the homeowner has no hot water because we can't flow to the tank. So that becomes a real problem because, okay, they've been down for a day. You come out there and see it's a load pump. Well, now you've got to order a load pump. So you got 3 or 4 days there where you're waiting on the part. So all that time, they're not going to have hot water. They're really not going to be happy about that. We found that out. So we do recommend that you do install a backup water heater, and that can be electric or gas. We don't really care at that point. But it's kind of similar to how we did if you've done the superheater piping on a standard unit and you put in a gas water heater, we would have kind of like a preheat tank. That's kind of what we're going to do here. We're going to preheat the water in the TurboMax and send it over to your electric or gas water heater. And then if it needs to be heated further or the TurboMax is not operating, then we would still be able to supply hot water to the home in that situation. So I would recommend installing a backup water heater as well for if the unit does go down. We do recommend home run style piping. What we mean by home run style is all the valves and controls and where they end up all come back to the mechanical room. If you put the zone valves at the unit, then you're going to have to get to those units to see if they're open or closed. When you're flushing, it's going to be a pain in the butt to, especially if they're in an attic or a crawl space. You really don't want to be crawling in and out of there all day checking out things. So if they're in the mechanical room and you're working at the unit, then you can walk right over to it and see if the zone control is open. So it's a lot easier to troubleshoot and to flush if all the controls and such are in the mechanical room back by the unit. So we do recommend the home run style. We do not recommend the branch style. You can do what you want. These are recommendations, but it's going to make it a lot easier for everybody if you do the home run style piping. So if you have a hydraulic separator or a buffer tank installation, these are all listed in the manual. You're going to need these different parts and pieces. So you might want to look through this, and I'm not going to go through every little thing that's in here, but you may want to look through this chart and see what you're going to need when you add the hydraulic separator or a buffer. We do have a newer variable speed pump. It's the UPM XL. We had the UP 32140, I believe it was, the Magna Geo pump, and that's not available any longer. And I think we may be out of stock at this point. So we are going to this newer Grundfos pump. It is more efficient. It doesn't pull quite as many amps. It doesn't do quite as well on pumping, but it's pretty close, so you shouldn't run into an issue of if you have to replace your old pump, the 32-140 with this 25-124, it should be able to handle it. I don't really see a problem. Make sure you're installing it in this configuration, never with that electrical box on the top or the bottom, always on the sides. And here is basically the flow center comparison. The dotted brown line is the 2699s. The Magna Geo, which is the 32-140, the older pump, is in the blue, and the newer, the 25-124 is the green line there. So you can see we're not able to flow quite as much, but hopefully it won't be an issue. If it is an issue, we'll just have to add an external pump into your system. Here's basically the different flow rates in the power and watts. So if we look at the Magna Geo at roughly the same GPM, we're going to be pulling a lot less watts. So it is definitely a more efficient pump. And we didn't really have a choice in that matter. Grundfos pretty much told us that they're not going to make the Magna Geo any longer, so we had to go to something else. This is the internal three-way valve, and it's used for shifting from hot water to heating and cooling. When you're flushing, it'll go through the setup wizard, and you'll have to move this valve into the hot water position so we can flush the hot water circuit as well. It is located in the back near the load pump and the load connections. If it has to be replaced, you're gonna have to take the top off the unit. You can remove just the head on it. If for some reason the head fails, it can be replaced by itself. Zone valves, we recommend using these Taco Century zone valves for your radiant or your hydronic forced air zoning. They have a low CV rating and they're super reliable. So we don't have many problems with these at all. They got a little light on there that'll tell you if it's open or closed. And you can also manually open these as well. You can remove the head if you need to replace it very easily. So we would highly recommend using these Taco Century zone valves. Pipe sizing, 1-inch copper piping. You can use these are in-floor manifolds in the picture here. Make sure when you're installing manifolds that they're in this horizontal position. Do not install these in the vertical position. If you do that, they're not going to vent air properly, and you could have problems with water flow. So make sure that they're in the horizontal position like they are here in this picture. You can order these in-floors. You can make your own. It doesn't really matter to me too much. These in-floors are pretty nice. You can order them in however many circuits you need. And I would recommend if you're running into a bigger manifold, you may want to run 1.25 inches or 1.5 inches copper piping over to it. Check out our IOM. There are some flow rates and pipe sizing recommendations in there. So definitely look in the IOM for proper pipe sizing. This is our air handler, our hydronic air handler that we're using right now. Hopefully that'll change soon. I don't know, I've been talking about a new air handler for about 8 years now, so I hope we're getting real close to it. That would be really nice. The air handler is really the only unit that we don't make in Mitchell. So there are some bigger commercial units we don't make, but as far as the normal Geo units, everything's made in Mitchell. So it'd be nice to, finally have our air handlers made at Mitchell as well. There are 3/4 copper connections on the unit that are stubbed out, but we do recommend running either 1 inch or 1.25 inch copper piping to it and use the zone valve as part of the zone control. I would put, if you've got a call for your air handler, I'd run it through your zone valve. And that way the zone valve opens before it actually gives a call to the unit, so we can make sure we've got water flow to it before we run that fan. We do recommend that you stick to between 2 and 5 tons. With the hydraulic separator, or excuse me, with the buffer tank package, you can go down to smaller air handlers, but you will have to have a buffer tank if it's smaller than 2 tons. The hot water tank, we kind of talked about this tank. You can't just go to your Ace Hardware and pick up a regular standard water heater and use it on the WV unit. Basically, it supplies almost instant hot water. So basically, your load water from the unit goes into the outer jacket or the actual bulk of the tank itself. And then there's a copper pipe that runs and it's kind of coiled up inside of the tank. And the domestic water from the home will enter the bottom of the tank, go through that coil that is surrounded by your 130-degree bulk water from your WV unit, and pick up that heat and then discharge out the top of the tank to the shower or the sink or wherever that hot water needs to go. The WV hot water coming into the tank enters the top and comes out the bottom and returns back to the WV unit. So we've got bulk water in the outer jacket and domestic hot water running through a coil and runs through the load water. And we do reverse return on the water flow. So the coldest water gets the coldest domestic water gets the coldest water from the WV unit, and vice versa. The hotter domestic hot water gets the hotter of the WV unit. Better heat transfer that way. Again, we kind of talked about the hot water sizing. These are all listed in the IOM. You need to size it. And then we also list some dimensions of the tank itself. Domestic hot water connection is an 1.5-inch sweat male copper fitting. The heat pump connection is an 1.25-inch pipe thread male fitting on the 45-gallon and 1.5-inch male pipe thread on the 65-gallon. There is a pressure relief, so if you flush it, either plumb it to a drain. That's probably what I would do, because if you get above, I think it's 30 or 35 PSI, then it's going to pop open that relief. And it's happened, it does happen. It's not a huge problem. You will drop some water in your flow center or your flush cart tank because you're going to discharge a little bit of water, but try to keep the pressure down so you don't. So try not to deadhead your pump on your flush cart when you're flushing the tank, or else you will definitely open that pop up. Not a big deal as long as you've got it piped to a drain. Just know that it will dump some water once you get up to that relief setting. Source side connections, again, they're closed loop only. If you're going to use an open loop, then you're going to have to put in an external heat exchanger to isolate the open loop from the unit. We can have that swept. They will not allow well water to be ran through the braze plates. So you're going to more than likely have a closed loop, and they're all double O-ring, even on the non-pressurized at this point. So it'll come with the hose kit and the double O-ring fittings for you. Again, we kind of already looked at this. We're not going to hash that out again. I would recommend using a flush cart with these filter socks. You've got a real white one and then that brown one. The white one is a 1 micron filter bag. The brown one right there in the picture is a 100 micron bag. So I would start out with the 100 micron, and it just basically goes over the return line on the flush cart, and it'll collect any debris. That's from rust, that brown look to it, rust and debris that was in the system. And these filter socks, they can be washed and reused numerous times. So if for some reason you don't have a filter sock, you could also get a pair of pantyhose, women's pantyhose, And that's about 100 microns, and you can use that, and then just, you can throw those away. And then after you've filtered with the 100 micron, then I'd go back through and filter with the 1 micron bag. We do offer these bags at Intertech, and we do have a new flush cart too. I ought to put the new picture in here. It's a real nice flush cart. We made this flush cart that's in this picture here, and we made the ones that we would sell before, but now we're actually getting our flush carts through Geoflow, and they're real nice. They have like a sight glass on the side with a little marker, so you can mark it and see if you're dropping the level in your flush cart when you deadhead the pump. It's got a way to even power flush with the new flush cart. So it's a really nice flush cart. I'll try to get that picture switched so people can see that next time. But I do have a flushing and purging video on YouTube that has the new flush cart, so you can check it out there. Source side flushing, make sure that when you're flushing, those 2 little blue lines indicate the hoses coming in from the flush cart. Make sure that you flush in the normal direction of flow. We've got that strainer in there, and so we want that strainer to help catch stuff as we're moving, as we're flushing. So make sure that we're always flushing in the direction of flow through the unit on the source and the load, because we have a strainer on the load side as well. So we're going to have to flush in the direction of flow on both the source and the load. On the load side, more than likely, you're going to require more than city water pressure to flush the system. Sometimes you can use like a transfer pump as well, but a flush cart's probably the best way. Isolate the system from the heat pump. Don't flush through the heat pump because we do want to go in the direction of flow. So we want to make sure that when we do flush through the heat pump, that we're going in the direction of flow. Make sure you're always filling the system with clean, good quality water. And Fernox is a treatment. We need inhibitors in our antifreeze and water mixture. If we don't have those inhibitors, there's different materials in the piping, valves, things like that, and it can actually start to break down those fittings. So we recommend an inhibitor. We use Fernox, and we actually have a Alpha 11, which is a Fernox antifreeze and inhibitor mixture that we sell. We sell the inhibitors, we sell cleaners, all from Fernox. Always test your water before you're throwing it into the system. We have a test kit that'll do, 150 tests that you can purchase. There's little test strips, and you can keep it on your truck, and you can test water quality. If you don't feel comfortable doing that, you can always send me a water sample. I can test it with the kit, or if you need it documented as far as like through a testing lab, I do have a laboratory that I can test. I can send it off to be tested. We will charge you for it, but we don't mark it up or anything. I think it's like last time I checked, it was $128, and I need 32 ounces of water. You send me the water, I'll send it off to the lab. The lab will email me the results back in about a week. About 5 days, I should say, and then 5 business days. And then once I get those results, I'll give you a call and we'll discuss those results, kind of go from there. Again, isolate or plug the relief on the water tank, or you will purge air or purge water out of it. And then the last step you're going to do when you're doing your load flushing is you're going to have to turn on the unit and go into the startup wizard, and basically it's going to energize the hot water circuit and shift that 3-way valve in there so you can flush the hot water circuit. Basically on step 1, we would prefer you to flush the domestic hot water circuit first, and you can flush through the unit and through the tank in the normal direction of flow. Make sure you've got your valves open for the tank and that they're closed off. If you've got a hydraulic separator or a buffer tank, close off that circuit, and we're just going to flush through the load in, and then through the domestic out, through the tank, and then back to the flush cart on the flush cart. Excuse me. The next, we're going to close off the tank, and we're going to hook into the boiler drain that's down there. There's a small little circuit in between your flush block on your load and the tank there. There's a little bitty circuit there we're going to need to flush. So we'll flush that out real quick. The next, we will flush between the buffer tank or your hydraulic separator, whichever one you have, and the unit. And again, remember to flush in the normal direction of flow. After that, we can go up on the other side of your hydraulic separator or buffer tank to your external field installed flush blocks, and we can flush between there. And in there, when you do the external pumping, you've got that little triangle there, that's your external pump. You're gonna probably wanna put a bypass valve in the load in and load out lines, so that if you don't have proper water flow or you can't get enough flow, this pump is pushing too much flow than what's required for that zone, the extra flow will be bypassed and return right back to the hydraulic separator or your buffer tank. So we want to flush out that bypass. So close off all your zones, and we'll just flush through your bypass. Then we're going to flush through your furthest away zone. So close off your bypass circuit and flush through your farthest zone away. Then your next farthest, and then your next farthest, and so on until all the zones are flushed. Then go ahead and open up all your zones and flush through it all. Go ahead and open up your bypass at that point, and we're just going to flush that whole circuit again real quick. Make sure you open up all your zones, all your ball valves, things like that need to be opened. Set your flush ports into the off position, and make sure all the other valves, your hydraulic separator, your buffer tank valves are open. Your domestic, your Turbomax tank valves are open. And if you've got a blowdown valve, make sure it's closed off. But these are just the normal positions of the valves once you're ready to operate the system. Load side antifreeze. Anytime you're cooling with chilled water, we require antifreeze in the load side of the heat pump. Now, if you only have one zone out of 6 zones that are doing chilled water, you could install another heat exchanger in between those and isolate it, and then only put antifreeze in that one zone. That's totally up to you. But anytime we're doing chilled water, we want to make sure that it doesn't freeze and break something. So the heat exchangers are braze plates, and they do not handle freezing very well. You freeze it once, you might get lucky. You freeze it twice, you're probably going to be out of luck. They'll swell up and they'll break those plates. Then you got water in your refrigerant circuit, and it's a big nightmare. So make sure that we're installing antifreeze on the load and the source. Electrical connections, we got low voltage wiring in the upper portion. The high voltage is in about midway, and that's looking at kind of the right side of the unit there. This is the control blocks. We've got the digital controllers, the iPro. We've got some heater relays. That green little box in the upper middle portion is your removable terminal strip for your low voltage. And then you have your high voltage coming in. Now we have 2 high voltage blocks, one for your immersion heater and one for the unit itself. And we have 2 pump blocks, one for a fixed speed or an external pump, and one for your variable speed pump. And they'll be labeled. They'll have stickers on them when you open up the cabinet that'll tell you what they all are. So when in doubt, refer to the IOM. It is possible that one of the employees in Mitchell put a sticker in the wrong place. So if you're ever in doubt or it doesn't look quite right, check the IOM or call us in tech support, and we'll confirm, placement. We do recommend a surge protector and possibly even a compressor defender. I'll have to talk to Jim about that. Surge protector is nice, with all these electrical controls on here. A lightning strike or something can really take out and cause a lot of problems. So we like to put a surge protector on it. Again, there are 2 circuits, one for the geo and one for the backup or auxiliary heat, and it's 230 volt single phase only. Again, high voltage connections, they will be labeled, one for the immersion heater and one for the main power. Flow center, the variable speed flow center for your source and the load are controlled by the WV controllers. So there is an internal pump block that provides power for 1 or 2 pump flow centers, and there is an internal flow meter and thermistors that control delta T, or temperature difference. So it tries to maintain 5 degrees. It does have a little bit of a buffer on that, so if it can't respond quick enough, it's not going to immediately lock out if you get the 4 degree temperature difference. It's got a little bit of a buffer there. The low voltage connection, there's a 15-foot wiring harness that will plug into this MOLEX connector on your pump. If you're ever concerned about a pump, whether the pump is bad or if it's a controller issue with a variable speed pump, just disconnect the low voltage. When you disconnect the low voltage on the pumps, those pumps get confused. They don't know how to operate, so they run at 100%. That's a good way to know if the module on the pump or the motor itself is bad, is just by unplugging that MOLEX connector. Almost immediately, it should start operating and it'll run at 100%. The high voltage connections are located inside the pump, a little box there on the flow center itself. And again, these will be labeled. You have your fixed speed pump, so that's an on-off. The unit will decide when it sends 230 volts to that pump block. And then you have your variable speed power block, where that pump block has 230 volts all the time. A variable speed pump is similar to a variable speed ECM blower motor, where the motor has high voltage all the time, and the on-off or how it's controlled is based on the low voltage. I really wish that the blower motors, when you unplug the low voltage, would go to 100% as well, because that's what usually fails on a blower is the module. So it'd be nice if they would do the same thing these pumps did, get confused and just go to 100%. I mean, it's better to have some flow than no flow. But I guess that's not real relevant to this training, but sometimes things get on my mind and I say something. So again, this is the low voltage signal connection for the flow center. We do give you 15 foot. We don't really want the flow center 15 foot away from the unit, but if you have to go up a wall and over and back down, we wanted to make sure you had plenty of extra play in that wiring. This is the pump controller. You can actually go, when you get to the HMI, the human machine interface, it's kind of hard to see in this picture here, but if you'll see where it, on the bottom has those dark colored boxes, it says main, comp, pump. But you can see the pump, it's kind of whited out there. There's actually a button below that. So if you were to press main, it'll go to your main screen, it'll go to your main screen. If you press compressor, it'll go to your compressor screen. We press the pump button, which is right underneath where it says pump, and it'll take you to your pump screen. Now, you'll see like a little volute there. It'll have these little black boxes, and they'll be spinning if the pump is moving. If the pump is not running at all, the volute will just be kind of clear or white. But it'll tell you the percentage that the pump is running in. If your flow switch is made, it'll say yes. If it's not, it'll say no. It'll show your flow and your GPM, and it'll show your entering and leaving water temperatures as well. And that's for the source and the load. Electric immersion heater, again, it's built into the unit. It's 9 kilowatt, 2-stage. You could leave it disconnected. There's ways to set it up in the controller to have a delay on it. You can turn it all the way off, but it will require a separate 50 amp circuit. And there is basically the pump block for the heater if you're going to run your power in from the breaker panel, and there will be a sticker located on it. Low voltage, this is your removable terminal strip here. These are dry contacts, so no power goes through here. It's just an open or closed circuit. So Y1 and Y1C, that's your radiant heat call. Your Y2 and Y2C would be an air handler heating call, which would be a higher heating temperature. The O and OC, that's your cooling call. HW and HWC is your domestic hot water call, and OAT are your outdoor air temperature sensors. That's where they're going to be mounted into. Let's take a quick break, about 5 minutes, and then we'll get into some of the controls and a little bit more of the screen stuff, and then we'll probably end a little bit after 11 today. So give us about 5 minutes, and we'll be back with you about 10:27 or so. Thanks, guys. All right, let's go ahead and get started back again, guys. We'll go over a little bit of the hydro connect control, zone controls. We're not going to really get into a lot of the actual wiring of it or anything like that, because every installation will probably be a little bit different. So I just want you to see the different controls we offer. We offer the hydro connect controls from Geoflow. It'll come on this nice little board. This is actually maybe an expansion module, but you got the TACO zone board, and we've already pre-wired your relays. And so this is more of a plug and play type setup. It's pretty nice. There you can see a little zoomed in version of that TACO board. It's a pretty standard board. You may have used one in the past. This is what we would recommend. In the IOM, it will list this wiring diagram selection chart. So you can look in here and see if you have a heating and cooling dual fuel that you would use the HTG CLG-3 diagram. And that diagram number, as you scroll down the IOM, it'll bring up these wiring diagrams. So you can see if we've got a heating and cooling dual fuel, which is right there in the middle of the screen, it'll be able to do up to 5 radiant and 1 A coil, which is a dual fuel zone. And it'll have 1 A coil, so you can do heating and cooling with it. Minimum tonnage is 2 tons, and it'll tell you the zone control. And then it'll list some notes on different types of thermostats you can use. With the Hydro Connect, you can usually bring your own thermostats. If you get into some of the HBX controls, you'll have to use the HBX thermostats. Just some notes on zoning. More than 6 zones requires another zone control for an additional 6. Just talking about some different thermostats, not really going to get into that too much. You can use, we would recommend if you're going to use air handlers that use the MPH fan coils. We can get into some of the multi-aquas, but again, if you're going to get into a smaller air handler, make sure that we're using a buffer tank. If it's 2 tons or larger on the air handler, then we can go ahead and use the hydraulic separator. So these are just some wiring diagrams. Again, this is a radiant heat only, up to 6 radiant zones. This would use the Hydro Connect zone controls with the TACO zone panel here. This is heating and cooling. This is 1 fan coil and up to 5 radiant zones. Again, you don't have to really worry too much about the uppers, relays and stuff. We've already wired those in for you. You're going to be wiring in your fan coil and your thermostats and things on the terminal strips. And those terminal strips are labeled very nicely. So here's heating and cooling, 1 fan coil, 5 radiant zones with ducted zoning. So just another setup for that. If you have some dampers and some zone ductwork, there's a wiring option for that. This will be a dual fuel backup gas furnace with 1 fan coil and 5 radiant zones. Heating and cooling, a fan coil only, no radiant heat. It's a little bit different setup. Here, again, I'm not going to get really in depth with these today. I just want you to be able to see what we do offer. Heating and cooling, fan coil only, no radiant heating with an MPH fan coil. And this one, we're going to be using an EWC zone panel. And here's another one. We've got heating and cooling, fan coil only, and we're using a multi-aqua or another fan coil. There's some setups and things you have to do, but we've listed it pretty well in the IOM for you. This will be a heating and cooling up to 6 radiant floor or fan coil zones that we're going to require a buffer tank. So if you got a buffer tank, this is going to be the setup for that. And we're going to use the HBX control on this setup, the HBX Eco 550. Just another little wiring diagram of the 5 radiant zones, 1 fan coil zone. This is the expansion panel. So if you have, let's say you already have a fan coil and 5 radiant zones, but you have an additional fan coil and 5 radiant zones, you can add this expansion panel on and you're able to handle those needs. One thing I do want to say, I don't really care how many zones that you have. Just remember that if all zones are calling, the unit is either an 040 or an 060. So it can only produce 3.5 tons or 5 tons. If you have 10 zones and that takes 10 tons and they're all calling, the unit is never going to be able to handle it. So just because it can take 10 zones doesn't mean that it should. You just have to remember it's a 5-ton unit or a 3.5-ton unit, and keep that in mind when you're putting out these different zoning needs. Here's a single buffer tank up to 6 zones with pumps or valves. With your radiant zones, you can pump them or you can use valves, and we have a setup for that as well. This is going to use HBX control as well. Moving on to our hot water set point, basically the aquastat on the tank is going to provide a dry contact for your domestic hot water call. Basically, how we're going to set up the aquastat. So if the aquastat satisfies and the leaving load temperature does not exceed 135 degrees. We don't want that leaving load any higher than 135. A lot of times they set the tank temperature, I see out in the field, around 120, 125 degrees. Obviously, if we can go lower than that, we will, but that's normally where we set it. Basically, we're going to monitor the tank gauge until the leaving load on the HMI does not exceed that 135 degrees, and we can tune that aquastat while it's running. So if the compressor shuts off, but the tank is still calling, you've gone too far and the unit's reached its max temperature, basically. So we'll have to dial that set point down a little bit. I don't really care what the aquastat is set at. We just don't want that leaving load temperature above 135. Aquastats can be off by quite a few degrees straight out of the box. So just make sure we're not getting too hot of water. Outdoor reset, we talked about that a little bit with your outdoor air temperature sensor that comes with the unit. Basically, we'll use that outdoor temperature for our outdoor reset control. So with the efficiency of the unit or the COP of the heat pump going up as the load design temperature goes down, then outdoor reset makes a lot more sense as a control strategy. It's basically going to vary your design load based on your outdoor temperature. So the colder the outdoor temperature, the warmer the water will be. When it's 50 degrees outside, we don't need 120 degree water running through your floor to get temperature. So we can lower that water temperature and improve our efficiency of the unit. Again, the thermistor is included with the unit. And if for some reason it fails or is broken or you can't get it installed, there is a static set point in the HMI for a failed sensor. Make sure we're normally positioning that sensor on the north side of the home and that we're avoiding sun exposure. That'll cause it to give a wrong temperature reading. This is the heating curve. In the older generation of the unit, we had, I think, 8 curves. Now we've got 15. Normally, I think it may come from the factory at number 3. I'm not positive on that, but I'm pretty sure. So here where we're located here in Illinois, it's usually around 3 or 4. But depending on your area is going to depend on where you kind of put your heating curve at. And you can change it at any time if you don't like where it's at. You can definitely change it very easily on the HMI. Here's a little chart of the COP of a unit. Basically, you can see how it'll raise. We're showing the temperature difference between the source temperature and your load temperature. So as those get farther apart, the COP of the unit gets closer together. So if we can have, a 20-degree temperature difference, we're going to be running a pretty good COP of like 7.5. As it gets farther apart, we're going to drop down. So you also have to take into consideration tube spacing and sizing, your insulation, your floor covering, and the types of baseboards that you're using as well for those temperature set points. So the startup wizard, when you first power up the unit after you've got it installed, it'll take you through the first run setup. It'll tell you right on the screen, first run setup. Do you want to start? And you can just press next. Here's actually the actual screen. It's going to keep the pumps, compressors all off until setup is complete, and it'll guide you through the flushing of the load, because again, we have to move that hot water valve to make sure we flushed the domestic hot water circuit. It's also going to ensure that we have minimum pump flow on the variable speed pumps. And it'll review some of those settings and won't lock you out if you drop too low a flow. So it'll give you time to kind of adjust things. So the first thing we're going to flush. So it's going to take you to this. And if it's in-house and you need it to go to the hot water mode, then you're going to have to scroll down until you get to this little house word, and it'll be kind of darker. You can press enter and you can change it, and that valve will shift for you. So that way you can make sure that you've got the load and your hot water circuit flushed out. After that, after you've switched that over, it's going to remind you, hey, before you go to the next step, make sure that it's flushed. If it's not, then you need to go back and start over again. But it's just kind of warning you, hey, I'm going to turn the pumps on, so make sure that it's flushed. So as long as you've got it flushed, you can go ahead and go to the next screen, and it's going to show your load and your source pumps, and it's going to bring up a pump minimum speed. We want that pump minimum speed. I don't really care where it's set at. Whatever that minimum pump speed is, it needs to make sure that our flow is above 5 GPM. So if it's 25%, then so be it. I see on the load, it's about 60% is your pump minimum. Somewhere between 45 and 60% is what I normally see. So you can start out whatever it is when it comes up on the screen and see where you're at. It gives you a chance to kind of play around with it. And you can see how the 25 here on the load pump is highlighted. Once it's highlighted, you can move it up. You can press enter and move it up or down on your percentages. And you can look at your GPM and see what your flow is. So this is where you can also set up your bypass valve if you've got a bypass valve set up in it. So we can make sure we've got proper water flow through there. Do it on the load and the source. And make sure that whatever the pump minimum is, that you have where it says estimated flow, you have at least 5, and that it says flow switch yes. Next, it'll ask what your max heating set point is. So if you set it at 135, but you need floor protection, it will still look for your floor protection. The 135 is the max temperature it ever wants to see out of that unit. So that's the max temperature it would send to the air handler. If it sees a radiant floor call, then you can set your floor max temperature as well in a later screen. You can set your heat curve here as well. Again, I believe it comes from the factory at number 3, but you can change it. Again, the unit will run on your heat curve for the floor heat. So it'll always override whatever your max temperature is. Again, we covered the heat curves already. After you've gotten your heating set point set, it'll say your first run setup is complete, and you can go back or you can exit. Once you exit, if for some reason you decide you need to run your startup wizard again, there is a button on the screen where it says Setup Wizard. You can press that again, and it'll take you back to your actually says Startup Wizard. Your Startup Wizard. You can run it again and go back through it. So if for some reason maybe you don't have the domestic water hooked up yet, or you don't have the load hooked up yet, vice versa, you could run it in whatever mode is piped in and ready to go, and then come back later and put the tank in or whatever and go through that setup again and flex that valve and flush the circuit and then run the unit. So just gives you an option to be able to do that. So sequence of operation, that when you finally are finished installing and you're ready to run, you start it up and you give it a call. The pump is going to start. So the source and load pumps are going to run for 1 minute. Then it'll say equalize, and your expansion valve is going to open to 100% and make sure that the pressure is equalized. And then you will go and do compressor start. The expansion valve is going to be about 40%, and it's going to run the compressor at minimum speed for about a minute. When it runs in that minute, it kind of is allowing things to kind of stabilize and start to read temperatures and settings and things like that. Then the compressor it'll say running or heating call. The compressor is going to modulate to reach its target load out temperature, and it'll show an RPM range on the screen of its target range. And then the expansion valve is going to modulate, and it tries to maintain 10 degrees of superheat. Then the pumps will modulate on their own to try to maintain your 5-degree temperature difference while still obeying your minimum pump speed. So if your minimum pump speed is at 25%, you're running at 25%, and you're at a 3-degree temperature difference, it's not going to slow your pumps down any farther than that 25%. That's just how it's kind of set up there. On a compressor stop or an end of a call, the compressor is going to ramp down to 0, and then the pumps are going to ramp down about a minute after that compressor is stopped. It will then show on the screen ASC, and that's a 3-minute anti-short cycle timer. After that 3 minutes, if there's no call, it'll just say idle on the main screen. Variable speed control. The compressor is controlled based on outdoor air temperature. And there's a target temperature for the compressor as well. So the temperature curve or the manually set. So the WV monitors the current load out temperature, and then it will throttle the compressor based on an algorithm in the controls to maintain that target temperature. When you look at the screen, it's showing your pumps, it's showing your temperature differences. It'll show your actual supply temperature and your target supply temperature. That target supply temperature is looking at outdoor temperature and the speeds and on temperature difference, and it says, okay, this is what I should be at. This is what I'm going to try to get to. As the demand changes, so zones open or close, the compressor will throttle and maintain your target temperature. If you've got a small zone, and it is possible to either overheat or overcool that, overcool it, the water itself. So if that happens and the compressor is running at minimum speed, the compressor is going to go ahead and shut down and continue to circulate your pumps. And then after the temperature is back in between that 5-degree temperature difference and that 3-minute anti-short cycle has expired, the compressor will start again. So it's not going to lock out the unit or anything like that. It will shut the compressor off, still run, still heat until it's back within range, and then it'll turn your compressor back on. It does have a differential overshoot of about 3 degrees, so it'll give it a little bit of a buffer there. Switch over. If you're switching from heating, cooling, or hot water, the unit does not shut down. The compressor will ramp down to minimum speed, so that's 1650 RPM. Then the reversing valve, if you're switching to cooling, or the 3-way valve, if you're switching to domestic hot water heating, will either energize or de-energize, and then the compressor will ramp back up. So we don't lose that 5-minute anti-short cycle between modes like we do in some of our other units, you know, WT unit or a packaged unit or something like that. So we don't really have any real downtime. That's real nice, especially when you're switching from your load water heating to your domestic hot water function. You'd hate to have that 5 minutes waiting on it to heat up your hot water for your shower. HMI, the human machine interface, this is the main screen here. It provides detail about the system operation. There are little black buttons underneath where it says main, comp, pump, status, system, and menu, and also alarm. And you can press those buttons and it'll take you to those different screens. On the main menu, it'll show your mode, which is either normal, test, manual, or emergency mode. It'll list your call, whether there's heat, cool, hot water, or none. The current status. So here it says STRT, which is in the startup mode, but we also have equalize, run, shutdown, AST, idle, and lockout. The main menu will show this little compressor animation, basically. Underneath it, if the compressor is calling, it'll show the operating range. And sometimes it might be based on your outdoor reset, it might be, you know, 1650 to 4500 RPM. So it'll list that, and then it will also list if your compressor is running, what RPM it's running at right now. There's also there's some black bars that will run up and down this little compressor looking thing in the picture and show that the compressor is running. Now, if you've got the door off or you're at the unit, you're probably going to realize whether the compressor is running or not, but it will show some animation there as well. The pumps, again, it'll show you these little volutes with those little black squares. They'll be spinning around and it'll show the commanded speed of that pump. The electric immersion heaters, it'll let you know if one or both of them are on. They'll be filled with the little black boxes as well. So if one stage is on, it'll be blacked out. If both of them are on, they'll both be blacked out. So that's what those little squiggly lines mean. At the very end of the main screen is your electric heaters. If you press the comp button, it will take you to the compressor menu, and it will show your compressor feedback. So it'll show you what the RPM is, the allowable RPM range, the current load supply temperature, the target supply temperature, and it'll show your inverter, your inverter temperature as well. And it'll animate if the fan on the inverter is on as well. Pump menu, here it will show you the both pumps, what the entering and leaving water temperatures are, the GPM, whether your flow switch is open or closed, and the percentage that the pump is running. It'll also show the volute again spinning. Stats menu, here it will show you your superheat, your load BTUs, your source BTUs, the suction pressure, suction temperature, discharge pressure, and discharge temperature. It will show your heat of extraction or rejection, but it will assume that you're using 15% methanol. So if you were to calculate it by hand, your calculation could be a little bit different than what's actually on the screen here, but it should be fairly close. The system menu will show the call, so or the mode. It'll also show, you know, it's a normal mode, test mode, manual mode, emergency mode, your call, whether that's heating, cooling, or DHW, domestic hot water. It'll show you your status, which this happens to be in a short cycle. It'll say run, idle, startup, AST. It'll show your diverting valve position, your reversing valve position, how many stages of heat are calling, your outdoor air temperature, which we must have a thermistor problem, or it's sitting on top of the compressor. It's about 327 degrees. Actually, it's probably not sitting on top of the compressor, but shows your load coil temperature and your source coil temperature as well. Then your menu. In your menu, there's 4 sub-menus where you can get in here and adjust things. We have indoor climate, hot water, pumps, and system. And then you have, they'll have some buttons across the bottom. You can choose 1, 2, 3, 4, 5, or 6, depending on what you're in. And it'll show settings regarding sensors and pumps and things like that. On indoor climate, you can put it on, in your heat mode, you can put it on standard, which is no electric auxiliary. You can put it on normal, which is a 20-minute auxiliary delay, or an economy, 40-minute auxiliary delay for your auxiliary heat. You can set your priority, whether that be cooling or heating. So if you get a home heating or cooling need, you can decide which one comes first. You can actually go in there and adjust your electric heat delay to a different setting than those 20 or 40 minutes if you'd like. That's totally up to you. Your cooling set point, I probably wouldn't mess with it too much. 42 is about the minimum we want to see, and we recommend 45. Here you can adjust your heat curve without going back through your startup wizard. And then it'll also list the heat max set point as well here. If you go to the hot water, it will choose whether you want hot water mode normal, so auxiliary after 30 minutes, or no auxiliary, and your hot water priority. I would always choose hot water as a priority, only because I would rather take a hot shower than worry about my radiant floor for 10, 15 minutes. You can set your hot water set point and your hot water delay for your auxiliary backup. And then your pumps menu. Here's where, if you need to run your pumps to check them out, you can put them in continuous and your control mode in manual. And then it'll run your pumps at this all the time. You don't want to leave it in that mode. I guess you could if you really wanted to, but I wouldn't recommend it. But if you need to test things out, then you can put it in manual mode and can run those pumps. If you ever run your load and source pumps and you see that the flow, it's going to be reported in GPM. If you see it bounce around a lot, let's say from 9 GPM down to 2, back up to 8, over to 6, if it just bounces around a lot, I can tell you that means you got air in your system. You may say, well, I just flushed it. Sometimes those micro bubbles don't want to come out. Again, that's why we've incorporated the hydraulic separator and the buffer tank to kind of eliminate those issues. So if you do see it bouncing around, know that it's almost positive to be air in the system. Control menu, again, you can go in here, you can turn the compressor off, you can set it at a certain RPM. If you're having problems with the unit, it's probably best to go in there and set it at a fixed speed so that it's not bouncing around trying to adjust. So this control will be to manually test the system. You can put your pumps in 5, 60, or 100%. You can switch your diverting valve, reversing valve, and your electric immersion heaters. So here you can go to the control menu and test out the system. We have a superheat menu. It'll show you what the superheat is set at. You can go in there and change it, but with the engineering support. But if you think you need to change it, call us and we'll discuss it and kind of go from there. And if we decide that we need to change it, then we'll let you know how to do that. So again, the human-machine interface, all measurements are for reference only. You can verify them with your, your refrigerant gauges, your pressure gauges, your temperature, your thermometer, and make sure you're always installing pressure temperature ports in the system. We still need those pressure temperature ports on the load and on the source. And if you've got a buffer tank or a hydraulic separator, I would install pressure temperature ports on the zone piping near your pumps for your external pump as well. Faults and alarms, they will show a little flashing triangle in the upper right corner on the HMI, and then the alarm button in the lower right corner will flash as well. There will be an audible alarm, a little beeping noise. It's not super loud, so if they're on the other side of the home, they may not hear it. And it will show on the status as lockout. If you press the alarms button on that last screen here in the lower right corner, it'll take you to the alarms menu. Now, when you get to the alarm menu there on the lower, you can see the little red lines there. There's 3 different alarm menus. The iPro, which is the one you're in now, the EV2, and the probe. So iPro is where you're normally going to find most of these. It's going to be your system faults and alarms. Your EV2 are your variable speed drive faults and alarms, and the probe are your failed sensors. We don't have sensors fail very regularly. Normally, you're going to fault out on flow or high pressure, low pressure, something like that. So it'll normally be on your iPro screen. Now, when you come to your iPro screen, it's not going to go to the actual fault. It's going to come up to CO1. Now, CO1 has dashed lines in front of it, so we're not locked out on CO1. Now, CO1 will tell us that that's a low pressure, but that's not what we're locking out on. We need to scroll over to where it says fault. Here it happens to be C11. If you scroll over and get to C11, it will say load loss of flow switch. So it sees the switch is open. You could have multiple faults. A lot of times when we see a C11 fault, we'll see, I think it's a C10, which is a load loss of flow feedback. So sometimes you'll have 2 that really kind of go along together, but you could have 2 faults. Once you get to the C11 fault, you can actually go over and it'll explain a little bit about that current fault. The C faults or the iPro faults, I think there's like 22 of those. So there's a couple different screens. So you can have to scroll through different screens to get to the fault. We do have a fault history. So if you're in the iPro and you want to see the fault history, press the iPro button again, and it'll bring up, sorry about that, got a little happy with my clicker. It'll show your alarm history. That alarm history will show how long ago that happened, and it'll show that in hours and minutes. And it'll hold the most 10 recent indefinitely. So if you kill the high voltage power to the unit, it will still, and you turn it back on, it'll still hold those faults. If you look really close in that bottom picture, we had a low loss of flow feedback, 3 minutes ago, 7 minutes ago, 10 minutes ago, 12 minutes ago, and 14 minutes ago. So it'll kind of show you how long ago those happened and what faults those were. You can see these are some of the different faults and alarms. We have low pressure, high pressure, those are switches, transducers, high entering, leaving load and source water temperatures. I'm not going to get really into a lot of these today. These are all listed in the IOM. And also you can go right to the screen on the HMI and it'll tell you. But again, we have like 20 some different faults here. Compressor running out of envelope, source coil minimum temperature has been reached, things like that. There's also, drive faults and probe faults. You can also scroll through those. Those don't happen real often. We'll get into a little bit of troubleshooting, not as much today, but basically got to understand the sequence of operation, how the system works. Heat of extraction and heat of rejection still apply to this equipment. And we're going to use onboard controls for the diagnostics and readings, but we always want to back those up with trusted tools that we carry on our truck. We've got to have water flow. That's the biggest thing we have problems with this unit, is locking out on water flow. And it tends to be more on the load side than it does on the source. This thing's real sensitive to micro bubbles. So just make sure we're sizing piping properly for a good flow, and for that we're not trapping air in certain areas. Same thing with the source. Make sure we've got proper loop field, and make sure we're adding a little bit of extra loop for the domestic hot water feature. Got to have power to the unit, obviously, and make sure that the compressors and all your pumps are operating, that everything in the circuit is operating. Can't expect the unit to work real well when our load pump has failed or compressor's not pumping. We're gonna kind of go through all this pretty quickly. Minimum pump speed is a big deal on source water flow. Again, it's usually up around the 60% mark. So you may want to start up at that point, but just make sure you're sizing pumps properly, loop field, things like that. Load water flow. We've got to have proper water flow. If we're having water flow issues, the unit's going to lock out quite often. And so we may need to look at installing your hydraulic separators, your buffer tank, things like that. Low turbulent piping, be careful with closed valves, deadheading the pumps. It's not good when we deadhead pumps, so make sure you're installing the bypass valve in your zone piping. Always verify your minimum pump speeds. If it's set too low, then it will lock out on water flow. So, you know, I know you probably heard me say water flow about 500 times today, but that's what the normal problem we have with the unit is. And, you know, we've tried to address as many of those issues as possible, but we can't be out there with you when you set it up. So make sure you're setting your minimum pump speeds properly and your bypass valves. Got to have proper power to the unit. Remember, there's two 50 amp circuits, so make sure there's plenty of room in the breaker, and the transformer outside the home is sized properly for the home. So wire sizing, we need to make sure we got proper wire sizing. Controls, the easiest way to know if you've got a problem, the unit's not coming on, there's no call to the unit. Easiest way to know if it's a unit problem or a control problem, remove the terminal strip and jumper the unit. If the unit comes on and runs fine, then we know that it's not a unit problem, that it's more of a control issue. So it really helps you eliminate half of the circuit really quickly to know whether to look outside the box or inside the box. You know, is it a unit problem? Is it a zone problem? So just remove the terminal strip, jumper it out, see what happens. So I'm not going to go through all these troubleshooting things here today. They kind of repeat each other, but flow is going to be your biggest issue. We don't have a real problem with expansion valves, reversing valves. We don't shift the reversing valve very often unless it's in cooling mode. And we don't really have any issues with the electronic expansion valves. We've really, since they're driven open and driven closed, we don't have a problem with them getting stuck midway like we do on the thermal expansion valves. Now I will get into a little bit of troubleshooting on the control because they each do have a light. This is the expansion valve board here basically, and it'll have an orange flashing as normal operation. No lights would be an indication of no power or a bad module, and a red light would indicate a communication error. A lot of times that's just the connection between the two has become loose. So you may need to pull that off and put it back on there. It will show an open close status with solid and blinking orange lights, which is normal operation. The variable speed drive faults are displayed on the HMI, but it does have status lights. So a green flashing and a green solid show normal operation. Anytime you see a red or yellow flash, it'll normally indicate a problem. And it's based on the pulse count. I don't know what those pulse counts mean. You'll have to let me know what they are, and I'll check with our engineering department on that. Highly unlikely that we have that issue. So a few last installation considerations that I want to rehash, I guess. Unit clearance. We've got to have a little bit of distance between the wall and the back of the unit, and we've got to be able to get to the refrigerant components. So I would say 2 foot around the entire unit. And make sure it's sitting on a rubber pad slightly larger than the base of the unit. It's going to help eliminate any vibrations that could be transmitted into the flooring. Make sure you always verify the wiring and piping and accessories are the correct and that they're wired in properly. Double check your low voltage wiring on the control side of things. And make sure you're always following your national and local electrical and plumbing codes. The unit, again, needs to be located indoor with an ambient temperature should range anywhere from about 55 to 105, and located in a way that piping or other permanently installed fixtures do not have to be removed for servicing or filter, or for like your case filter. Don't put a copper pipe running right in front of it. Don't run piping right in front of your doors where you have to get access to the unit as well. Again, this is a case inlet fan. We do have a part, but again, you can just cut a piece of fiberglass filter material and throw in there as well. We do have these heating curves in the manual, and so we require an octostat setting not be set above the curves in these graphs. What happens when we get out of this operating range is we get a lot of vibration, compressor failures, refrigerant leaks. So make sure we're staying within the safe operating range, which is this blue box here. So make sure we're setting up our water temperatures appropriately. These heating curve, or this graph, we do list these in the IOM towards the front because we want you to make sure that you're following and staying within the safe operating mode of the compressor. We ran this a lot back in, I don't know, around 2012 with the WT water-to-water units, guys setting water temperatures 140 degrees, compressors are failing, and oil's not returning, and acid burnouts, things like that. So just not a good thing. We have one for cooling mode as well, so make sure we're always looking at the safe operating parameters for the compressor. And these are straight from Immersion or Copeland, the compressor manufacturer. Recommendations for the WV unit applications. Systems with fan coils 2 tons and larger, we recommend a hydraulic separator. Systems with fan coils under 2 tons, we recommend using a buffer tank. Zone piping is home run style to assist in purging and maintaining lower pressure drop, and also for servicing. Make sure we're installing a boiler trim kit that's going to include an expansion tank, air separator and air vents, pressure reducing valves if you've got some makeup water, and backflow preventers. Make sure you're installing the auto air vents in the highest system in your piping, or in your piping of your system. Antifreeze. Make sure we're always installing antifreeze on the source, and if you're doing chilled water, that we're doing it on the load as well. Test your water. Make sure we've got inhibitors in there. Again, we have the Alpha 11 that's already got it in there, but if you're using methanol or ethanol, you're going to have to put that inhibitor in there. We recommend using Fernox. There are some approved alternatives you can use as well, but we sell and have worked with the Fernox, and it's proven to do wonders for us. So. Flush valves, if you've got a buffer tank or the hydraulic separator, you will need to add external flush blocks to your zone piping. And it's also going to have an external pump. That could be variable speed, it could be a fixed speed, that's totally up to you. If you've got the hydraulic separator or the buffer tank installed on for your zoning, make sure you're putting a bypass valve installed in that circuit as well. If you're using in between the unit and the hydraulic separator or buffer tank, we don't need a bypass valve if the hydraulic separator and buffer tank are installed. If you're not using a buffer tank or a hydraulic separator, then we will need to install the bypass valve in between the unit and your loads to avoid any pump deadheading if your valves don't fully open or something like that. In strainers, they're installed with the unit or they're shipped with the unit because they're required. Don't just say, well, I don't need to put those in. They're pretty important. Brace plate manufacturer requires those, so make sure you're installing those strainers in the circuit in the proper direction of flow. Maybe I'm gonna put some valves near it so you can isolate it and clean it out as necessary as well. Domestic hot water. In typical residential applications, a second water heater is not necessary for capacity reasons, but for larger usage applications, spa tubs, multiple shower heads, you may want to install a second water heater to meet those hot water needs. And you can use a gas or electric water heater for that. And it's also used for redundancy. So if the unit fails, they can still have hot water in their home. So with that concludes the WV webinar today. If you got any questions, feel free to reach out. You can ask them here now, or you can shoot me an email. There's the contact number for tech support, as well as tech support email, and my email address as well. There's also, if you need some training, if there's training you want me to do for your personal dealer or you in general, you can email me at the John Pendleton at Intertech Geo or training@intertechgeo.com, and we'll get you hooked up. So again, thanks for today. This webinar is recorded and will be uploaded probably this afternoon to our library, so you can take a look at it there. So thanks again for joining me. I know it's kind of a long one today. I hope I didn't bore you too much, but most of them aren't like this. If you haven't been to any of our other webinars, we do normally have webinar Wednesday, and so I try to switch it up. I do the WV once a month roughly on Wednesdays, but we do other types of webinars. So check out our Enertech University homepage and look for those trainings. So thanks again, and have a wonderful day.